Hey math students, we're going to go over how to graph a sine function, and the process we will use can be also used to graph any cosine function. So say we were given this function y equals 2 sine of 3x plus pi plus 1. The easiest way to graph this is to alter the form of it. If we can get it to look like this, y equals a sine b of x minus c plus d, then we can use all kinds of translation rules, shifting rules to graph it very quickly. So the only thing that's amiss in this function is this inner part of the sine. We need to get that 3x plus pi to look more like something where it's a number times x minus a number. So let's look simply at 3x plus pi. If we just factor a 3 from both terms, we get 3 times x plus pi thirds. But again, we want it to be x minus something. So instead of x plus pi thirds, we're going to say x minus a negative pi thirds. And that's going to be inside of our sine function. We then finish writing the function plus 1, y equals all of that. We can now identify each of these numbers. Because these are in the same form, we know that a equals 2, b equals 3, c equals negative pi thirds, and d equals 1. So now, when it comes to actual graphing, the first thing we're going to do is graph one cycle of the function y equals sine bx on the interval 0 to 2 pi divided by b. This interval will be 1 period. So let's go ahead and replace our b with what we have, which is 3. So we're going to graph sine of 3x on the interval 0 to 2 pi over 3. So I have on this axis labeled 0 to 2 pi thirds. And graphing sine of 3x, it's just going to be a normal sine function starting at 0 and running through till it completes one cycle at 2 pi thirds. So we know it's going to be 0 at 2 pi thirds. It's going to be 0 at pi thirds. It's going to have an amplitude of 1. So it's going to go up to 1. It's going to go down to negative 1 and back up to 2 pi thirds. So again, we've just graphed one cycle of sine 3x on the interval 0 to 2 pi over 3. Now the next step is to stretch or shrink our graph according to our value of a. Since a is 2, that means our amplitude is now 2. And so this same curve that we drew, I'll label it 1. We're now going to stretch it up to 2 and negative 2. So it is the same graph, it just reaches higher and reaches lower. Okay, so now we come to C. C is our horizontal translation. We will shift the curve c units to the right if c is greater than 0, and to the left if c is less than 0. That's why it's super important to get this in the form x minus something, because our c is less than 0, so we're going to shift it pi thirds units to the left. So I'm going to get a different color marker for this. We're going to take each point, like I said, and shift it. So if we took this point and we shifted it to the left, pi thirds, this guy is now right here. And then we come up at, let's look at this one, pi thirds, also shifts back, so it's now here. And this peak that's in between these 2 points that we just shifted over is still in between, so it's going to be right there. And same thing, this 2 pi thirds goes back a full pi thirds, and it's now there. And this valley in between these 2 points that have just been shifted stays between them like so. We can now draw again a cycle. So we've just shifted our curve over pi thirds units. Oh, and it'll continue the pattern. It'll peak there and then go down to there. Finally, after we've done the horizontal left to right translation, all that's left is our vertical translation, which is determined by our d value. This says to shift it up 1. So the middle of our graph was y equals 0. It used to be the middle of it. It now shifts up. So I'm going to draw a dashed line right there. And our peaks used to be at x equals 2, but they're shifted up. So now our peaks are going to be at, our peaks used to be at y equals 2. Our peaks are now at y equals 3. So this peak goes up. This is an old curve we're not using anymore. This peak also goes up. All of our valleys go up. That's our only valley right now. And all of our y equals 0 will all shift up as well. Straight up. And this goes up. So now we can redraw our final graph connecting these points. Up, and then down, and then up, and this would come up, and then down. So, with all the colors and all the lines on the board, our final answer is this blue curve. I'll go ahead and erase everything we don't need. We now have this blue curve, which is the graph of y equals 2 sine of 3x plus pi plus 1. And like I said at the beginning of the video, the same process can be used to graph any cosine function as well.